Hello everyone, I hope everyone is doing good. So today we are going to discuss about the add method at a specific element at a specific index and the removal from a specific index in our array list. And uh, just like yesterday we discussed about the add method, today we will follow the same format. So we will review the code in the form on an IDE, and after that we will do some practice on a whiteboard by taking care of some use cases, so it will help us to learn more deeply.
So now we can discuss add at a specific index, or we can say insert method. So this is an add method at a specific index with an element. Now first what they are doing, they are calling a range check for add, and it's here we can learn not only the management of edge cases but also how to write a good code. So you will see they have a lot of methods which are only one liner or two liner, and they are not trying to put if they are making small methods for a specific purpose. So in this name you can see range check for add, so it's only specific to add. They are not doing like range check and inside of that they are adding if else if, because that make code pretty difficult to understand. And we will see later in a case of a remove there is also one more method which name is only remove check. So in this case this method name is giving us explicitly information, hey, I'm going to check only for add, so please don't use me anywhere else. So now we can see inside of this check what will happen. So as you understand, in case of a insertion, I want to insert an element at a specific point in an array. Under the hood in an array, if you are talking from the client perspective, so you will say in array list, but because we are inside, so we know there is a element data array, so we will think from that perspective. Okay, so once we are going inside, we are checking only one thing. Okay, is index is greater than size or index less than 0. So what this will code do, this will throw an exception. Again, check here a beautiful small method which will they are going to use on 4 or 5 other places, but they are not putting directly here. Okay, index and then the size. So reusing by making small one liner, two liner method, it always helps. Okay, so we can go back, so we can discuss a little bit this one. Okay, so what about index? Okay, for example, I have an array list of 10. It means I have an inside array is also 10. Now if I send index 11, in that case what will happen? 11 is greater than 10, it's true, so it will crash because I'm not inside of the range. But if I'm saying, okay, my size is 10 and index is also 10, so in that case we are not crashing. The reason is uh, because it's more like I want to add my element as a last element. Last element mean, for example, I have 10 elements and all of 10 are currently not empty, there is a data, so I'm going to put on a 11th one. So in that case I'm saying, okay, it's in range because we can increment one. Like, you know, array is a conjective memory and it also gives you the guarantee there will be no empty subspaces in between. You always have an element data. So after 10, if we add without any index, that still work, but in that case what will happen, ensure capacity will run, then it will give us a new capacity, most probably 15, and then we will add that on a 11th. So in this case it's same. It's kind of a like, it's, if I have a size 10 and index is 10, it means both are equal, but it's kind of a outside of our existing element, we can't put. So in this case range check will be pass, and then it will go here and it will send, okay, 10 plus 1 11. And now internally, just we discussed in our last lecture when we discuss about the add method, it will increase the our capacity, which will move towards now 15. But after that, what will happen? After that, we are calling again the same method which we already learned yesterday. So in this case, I'm saying, okay, element data index element data. So we can discuss a little bit more. So in this case, I'm saying, okay, this is the source array, this is the index. So in our case, for example, I want to put that element on 11th. So it will say, okay, 11, then the destination, and 11 plus 1, it will be 12, and then size minus index, how many? So in that case, it may be 15 minus 11, it will be 4. It will copy, and what will happen in that case, index on the 11th one, our real value will be copied, and the remaining 4s will have the the empty value because there is no data. Okay, now check if I have the index, I'm saying, okay, on 0, and we have elements around 10, maybe you can say 9, and we have a size of 10. So in that case, capacity will work, this will work. In that case, what will happen? I have element data, index is 0, then again, and what it is saying, okay, 0 plus 1 is 1, and then size minus index. So our size is 10 and index is 0. So it's saying, okay, do copy all the element by doing kind of a moving one on the right side. So it will copy all those, and then in the end we will put our method there at the index. And now we need to increase, which is size plus plus. This is our add method. Next we will go towards the remove method. So in case of a remove, today we only discuss with the index one, and in the next video we will discuss about the object one. Like if you ever use ArrayList, you know there are two methods which mostly we use: remove on an index, a specific index, or remove from against a specific object. So in this case, once you give me the index, so, and also think if you are in an interview, then also it's very important to think about the edge cases. Like here you need to think about the edge case, here is also. So range check, and this range check is different from the other one, and now we will see what is the difference. Okay, in case of a remove, what we want the element should be removed, and there is no chance of a capacity change because it's a removal. So in that case, what they are saying, okay, if index is greater than or equal to, so any of them, then throw an exception, because size, we are starting from the 0, and if index is equal to size, it means originally we have element size minus 1. So if index is equal to this, throw an exception. But in case of range and check, you can see it's not equal, because in that case it may be a last value, and we can increase the capacity, and we can add that number, and there will be no empty spaces in between. We will discuss in a use case that will give you more clear information. So now once remove range check, so once range check is clear, like the client give us a proper value which is coming in inside of a range, we can do the next steps, otherwise throw an exception. So in this case, again, you can see the same method they are using again. Nice. Then mode count plus, just like I shared with you yesterday, it's concurrent modification. Exception always they throw on the basis of this variable. Okay, so what will happen now? We already aware of index, element data, index. So what is this element data? Again, it's a very small beautiful method, so we can do directly this. It's a one-liner here, but you will see in the upcoming videos they are using this method on 4 or 5 places. So it's good to have a small method. So in this case, it's only casting to E, because you know we have an object kind of element data like this. So we have an object type. So object is a base class, we are adding everything, but once we are moving, we are using by using generics. So E means an object. So it will be e object. If maybe it's integer, it may be person, it may be shape, anything. So now I have a value which they are saying old value. Okay, then this is a small logic which is pretty important. If you are an interview, you should be good with these things, because these are the small calculations and you need to be good. Okay, so what they are saying, okay, size minus index minus 1. So for example, if we have a size of 10 currently elements, and I send the index of uh, 0, so in that case what will happen? 10 minus 0 minus 1, it means 9. So number of move is 9. So basically what they are saying, move the 9 elements from end. So in this case you will see, okay, element data, same element data, source position, from where we want to copy. We want to copy index plus 1, because index 0 we are going to delete. So we are going to copy from index 1 to which position? To 0. So we will do this in a use case and it will be more clear. So basically now we are moving our all elements one on a left. Once that is done, we have now the last value which is empty. Currently that is not empty. Currently that have a duplication now on array index 10, 9 and 8, both are same. So what we are doing, okay, we are saying, okay, put that as a null and minus minus size. So here we are putting minus minus first, size, and then null. You can understand, because size currently is the out of bound. It's always, index always start from 0 and size is always start from 1. So in that case we will do, okay, if it's originally it's 10, first do 9 and then it go to the 9 place and then it go to the null. By doing null, what we are saying, okay, GC, we are saying, okay, GC, when you start collection, the garbage collection, we don't care about this object which we are, that's why because we did the reference is null, so we don't know about this object no more. And when GC will try to check, okay, is any, this object has any reference. So from our side, from the JDK side, it's saying no reference, but because we are also returning to the user, maybe user still have that element reference. In that case GC will not collect. But on the other side, if a user is also not using now that object, there is no reference, so it will be cleared by the garbage collector. And yep, anything else? No. So yeah, for today this these two methods are enough. Now we will see the use cases.
I hope you enjoyed the code review. Now we are going to take some edge cases and we will test those. So first we will discuss about this edge case, and not an edge case, it's a case. For example, so our client is using our app and they are the client use this, and it's saying we have a total of 5 elements. So there is a very one important question, or maybe not a question, I will explain. So we have an array of objects inside of our array list. It means we are getting objects, basically originally they are in heap and we are referencing those. So our object array list is already referencing. So I created this to save some time. So basically these are the values. Assume our array list is used as a string or a character, so we are saying this. And as you remember, in Java we always do pass by value. So when the Java the client used list dot add a, basically that a is an object, it's a new character or maybe new string with a, and once that is passed as a value, we have that value which is originally the reference, the address. So that's why we take that address and we save inside of our array, in our array. So if you remember yesterday, we are doing something like this: element data, and we are putting on this size plus plus and e. So that so basically that e is kind of a address, we save that, and the reference to towards that. It's important now because once we will play with these methods, we need to think from this perspective. Okay, so now we are going to execute our first case, which is list dot add 10 1. So basically client is saying at a, I think 1 maybe not good, I will say A. So it will easily, we can differentiate between the address and the value. So it's saying okay, at index 10 put A. What will happen in case of a add? First we are going to check range check for add, which we saw in a code review. So it will check, oh we have only 5 and it's saying on a 10, throw an exception, and this is an exception and remove. So in first case it will be the crash. What's next? In the second case it's saying okay, at 4 put maybe B. Now in this case what will happen? We are, and assume for now there is, this one is empty. Okay, so it means our capacity is this but our size is this. So originally on 4 0 1 2 3 4 we already have this. So once range check is passed, then next it will check the capacity, and capacity is again passed because we still have empty, so there is no need to do anything, and then in the end it will go and it will put this value B. For example, this is also B, so we are saying okay 0x5, and this is a big O of 1 operation. Now we can discuss the next one. I want to put on 5 maybe Y. In this case what will happen? So we already have this full array. What will happen? So I need to do what? Range check for add, and you guys remember the range check code is like this: index is greater than size, and the other side the negative one. So in this case range check for add, in this case I am giving index 5, my size is 5, which is false, it's not greater than. So we are going now in a capacity. In case of a capacity, inside what we are saying send size plus 1. So we will send size plus 1, which is 6 now, and 6 does not entertain in the same array. So what will happen? Ensure capacity will increase the capacity just like we discussed yesterday, and now we will get the new array with the 7. So in that case, for example, I can make a temporary, not temporary, originally basically now first they will create for us, and then it will move all the values here, like all the addresses 1 2 3 4 and 5, and now we will have a next our address. So for example, index 5 y is here on 0x6, so we will put 0x6. So this is a big O of n operation. First we need to create a new array, then system.array copy, that will copy in all the values, existing values, and then after that we are going to insert. So this is the case which mostly take big O of n plus 1, copy all the elements plus 1 the insertion. I hope you understand this code. Okay, so which is our next case? Okay, so now we are saying okay, put at index 0, and also I'm removing this for now to save our time, because you are already aware of the ensure capacity. In this case what will happen? It will come, it will check range. Yeah, we are easily in a range. What's next? Ensure capacity. No need, because we already have enough memory to tackle this. Okay, what's next? System.copy. Okay, you need to copy first. What that will do, that will copy these addresses one by one to us next. You remember we gave the index plus 1 to move index and the length of this. So in that case this will move to 1, this will move to 2, this will move to 3, this will move to 4, and now here we will put our new object which is y. For example, this one is here 0x9, so now we are going to put here 0x9. So these are all now already shifted one, but I hope you understand what I'm doing here. Okay, so this case is done. Now we will move towards remove. By the way, how you can figure it out these. So in an interview, basically these are the edge cases which I will throw. And how I figure it out, one, I start thinking, okay, if I'm going to write the unit test for these cases, how many unit tests I will write? And I figure it out, I will write 4. One, where I want to crash the app, throw the exception. Second, where I want to check big O of n, so I will put at a 0. And then the third, I will put in the end where ensure capacity should work. So in that case, ensure capacity, once it's running, it's again a big O of n. Yeah, we are not moving our values, but still we are copying those on the same place in a new, and then we will add that. So it's n plus 1. Then also I did one more check, adding in between. So these are the edge cases, or you can think these are the unit tests. Okay, so now remove. So I'm going to call list dot remove 6. So in this case we have 5. And you guys remember, we have a different range check method for the removal. So in that we are doing index greater than equal to size. In case of add, we have only greater than. So in this case, 6 is greater than 5. Yep, it will throw the exception. But for example, we are calling 5. Then what will happen? Index is 5 greater than equal to 5. So basically we are trying to say, okay, out of boundary, because originally it's a 4, 0, 1, 2, 3, 4. So that's why we will throw the, and it will crash. Then next case is 0. Okay, so this one is an interesting case. First we can make these arrows. So this one is 0, this one is 1, 2, 3, and this one is 4. Okay, this is our situation. Now in a range check, this condition will pass easily. What's next? You remember we are calculating, we are doing some calculation which is called, I think so, shift or move. And the algorithm is size minus index. I hope I'm right. We will see. Okay. So here in this case, size is 5, index is 0, 1. So basically we are saying we need to move 4 elements. Okay. Now before going to that, we are also doing old value. So we created a E object. E basically now is a character or string, and we are taking that value by doing size. Here we use the index. So index is 0. So at 0 index, it will pass me this 0x9. So basically now it is going here. Make sense? Okay. What's next? Now we are going to move by using system.array.copy, which this is our source. I will say, okay, you need to move 4 elements. The length is 4, these 4, and I'm saying source, you need to start from +1, index +1, which is 0 plus 1, 1, from here to the index. So it will start moving like this. So it will do like this, and now this will be moved to 1. Then this will be moved to 2 because we moved here. Then this will be moved to this is 3 and this is 4, like this. Okay, so one rotation is done. We are still here. Now we need to update our arrows. So this case, now this is like no more. Then 02, 03, 04, and this is still 04. Okay, now there are 2 things we need to remember. One thing, now this array has no reference of this object which we removed, old value. So once we will give this to the client, now client is responsible for this, and once the GC will call, we don't care. If client is not using this, there is no reference, that will be collected by the garbage collector. If not, then it's okay, but we are the responsible for this one. So currently, because we moved one by one, there is still a duplication. So what we did in our code, if you remember, we did something like element data, if I'm not wrong, minus size is equal to null. So because size is already on it's 5, and we remove first that to -1 because we removed 1, so it's now 4. So basically it's like 0 1 2 3 4, and I'm saying okay, what information you have, do that as null. Okay, once this is null, this is gone. Now in this case, what will happen, once GC is going to be called, it's okay because we have only one reference, so it is not going to be collected. But the good thing is, if we don't do this, and somehow, for example, next one you remove this 0x4 at index 4, so basically we do not have this, you remove that, this is null, and this is not null, and we still have that value. So in that case, now object is still there, but it's not visible because size is already moved. So that's why we need to put null once you removed, so later we don't have unintentional memory leak. So for today, I hope you enjoyed. Everything is now clear. So see you guys in the next video. Bye.